Hi. Picture it's the 1980s and all these newfangled programmable devices were coming out. I mean, you always had your traditional EEPROMs with a little window on there where you could erase them with UV and you had to program them. But things like PLDs started to come out and other one-time programmable microcontrollers started to appear back then, but they didn't have the newfangled flash technology and self-programming and all that sort of thing. And you wanted to program all these newfangled devices. Well, it was a lot harder back then, and you'd traditionally have maybe, you know, if you were short on budget, you might have a desktop machine that, you know, might have had a keypad on it, something like this, and you could program your EEPROMs and a sort of like a limited selection of programmable devices back then. But what if you're a big company and you wanted to program everything? You wanted one of these newfangled universal programmers. Well, what did you need? Well, let's check it out. You needed one of these bad boys. This was the standard, the Unisite universal pin programmer, and this thing was the duck's guts, probably several decades actually. This one came out in 1986 and it was the first programmable universal pin programmer with removable cartridges. I'll show you all this in a minute. It all removes out. You could program virtually any device on the market, even devices that hadn't been invented yet, because DataIO were the leaders and they would guarantee that they would add new device support for anything that came out. And this puppy could literally program anything with the right type of physical adapter and things like that. And this was the industry standard benchmark programmer. To a lot of people, it probably still is. And it lasted, they supported this from 1986 when it first came out, well into the 96 and into the 2000s as well. First of all, it started having a data terminal attachment for it. Then they got DOS PC-based software for it, and then they progressed to Windows-based PC software, and they just kept supporting this programmer because the hardware in here was so comprehensive and so universal, and it could still program almost anything today pretty much as well. But they have dropped, now I believe, they've finally dropped software support for this, but they kept supporting this device for several decades, and this was the benchmark universal programmer against which all the others were judged on the market for, as I said, several decades. And if you were serious, if you were sending your, space probe to Jupiter or something, and you had to make sure that your devices were programmed correctly, you used one of these babies, because this one was even though it's not like multiple ganged and things like that, this was a proper production programmer that would program the devices properly, because a lot of these devices had to be, if you wanted to actually program and test them properly, you had to program it not only the right voltage using the right protocol and the right signal levels and everything else, but then you had to verify them at the extremes of the voltage rails and stuff like that. And a proper universal programmer like this bad boy could do it all. And I've always wanted to tear down one of these. I used this in the late 80s and the mid-90s through to probably the early 2000s at companies I've worked for, because it was just like the industry standard programmer. It cost an absolute fortune, but for any big company, this thing was an absolute necessity. And I can remember, I've never used the later Windows software. I always used the DOS software. I don't think I ever used the terminal one, but yeah, I used the DOS software for this thing, and I have fond memories, and I always wanted to take one apart. But I couldn't, because it was all, it had the calibration seals and everything on it, and it was like the holy grail bit of equipment in the company. It'd have its own section of the lab dedicated. It'd be often run by somebody who knew how to use the thing. Sometimes you couldn't just wander up, some Johnny-come-lately come up and, I want to program my chip. It was like, no, you had to find the priest who operated this thing. Anyway, I'm not sure what the price for this puppy was back in the day, but if you had to ask the price, you couldn't afford it. And it came with like the basic ZIF socket here, but all of these are actually removable. So we can actually just take these modules out like this. So this was your basic 40-pin DIP one, which would, if you had just your DIP packages, that's just fine and dandy. But, if you wanted to program your PLCC packages and stuff like that, you needed one of these adapters in here. Oh, look at that bad boy. And we'll take a closer look at these. But yeah, you could actually not only replace that, but you could also replace, swap out the entire module like that. Absolutely beautiful. And they made adapters for absolutely anything. And DataIO were the industry leaders in this, and probably still are. I mean, if you want probably the best programmers on the market, you're probably still going to buy them from DataIO. And of course, companies like this you would have contracts with them, and they would guarantee to add support for the parts you wanted and full production support, and it was properly done and verified and everything. None of this, Shenzhen market eBay programmers and stuff like that. The software may or may not work. No, these were fully verified and tested and certified. So anyway, if you do know the price of one of these back in the day, please let us know. And I've been looking for one of these on eBay for a while, but they're rare as hen's teeth in Australia. But one of my viewers just randomly emailed me out of the blue and said, hey, they were throwing this in the dumpster. Would you? And I saved it. I just couldn't let them throw it out. Would you like it? Yes, please. Thank you very much. So it comes from a secret squirrel organization that, well, shall not be named. It's Secret Squirrel. Not only do we have the base unit itself, but we also have another adapter. Look at this. I mean, these things would have cost a fortune back in the day. PGA, your pin grid array one, so you could get all these different bases. I'm not sure what they actually ultimately went up to. That's 1991. There you go. Made in the USA. USA. Fantastic. So that would have cost a fortune. And also, all these adapters, look, probably still, look, unused. How much would these have cost? Hundreds of dollars each back in the day. But these were adapters for your different size. If you wanted a 52-pin PLCC, you would buy the adapter for it and just snap it in. Beauty. So this was actually a fully self-contained unit, had its own operating system, ran on a 68,000 processor. It's got dual floppy drives here. One, I think you would use the operating system disk to actually run it, and the other would be the algorithm disk, the programming disk that you'd actually whack in, and you'd actually, we'll see on the back, you can hook it up to either a data terminal, an old-fashioned, serial data terminal, or in more modern times, a PC running DOS or Windows software, but it was still completely standalone. You just needed like a terminal to, to show you stuff on the screen and say, put in algorithm disk number 5 that supports the part that you wanted. I have fond memories of doing that, but I'm so excited. I always wanted to tear one of these things down. And this is going to have a lot of switching circuitry, hence the huge, massive size of this, because it is a true universal pin programmer. So it's going to have like a read relay switching on every one of the pins that you can switch through multiple programming voltages. Because you've got to remember, back in the day, these EEPROMs could, and in fact this one, no, that one doesn't have it, but this one here has the voltage written on it. There we go. The programming voltage, 12.5 volts. But of course, you wouldn't just program it at 12.5 volts. There'd be verification runs at different voltages and stuff like that. So, a lot of even the older EEPROMs, they went up to 21 or even 25 volts, if memory serves me correctly, for a lot of the old school ones. So this would support voltages at least up to that. And this bad boy, it's shaped like this because it's going to have all the cards in here, the pin switching and I/O cards. But let's take a look at the back. Look at this old school DTE. Yeah, it's even got switches for DCE and DTE. Hands up if you remember that. Data communications equipment, data terminal equipment. And you could actually hook it up to an old, VT100 terminal and still use this puppy. Anyway, this one was manufactured in 1987, so this came out in 1986. So this is, just a year after it came out. So it's basically one of the original puppies. Love it. Redmond, Washington. And one of the most interesting aspects of this was, as I said, this removable system like this, which was, fantastic. But do not touch pins. Ooh, sorry. I'm going to touch them. I'm brave. Little pogo pins in there. I don't know why they're not all populated. Maybe if you've got more I/O cards in there, actually, this one would only support X number of pins. If you wanted to buy like a higher pin count version, you could do that and probably have more pins and different adapters and stuff like that. But all the little pogo pins in there. But I always found fascinating, one of the most interesting things was actually this pad in here. How would you actually, where are the contacts? Where's Wally? Try and find Wally in there. I think you can probably tell what's going on here, but you would actually plug in your PLCC chip and it'd actually conduct through this conducting mat. So you'd have this 44-pin PLCC attachment, for example. That'd be a classic one, and you just whack it in there like that. Then you open it up and ta-da! You just actually put your chip in there. So these adapters just had like a spongy thing on the top just to put pressure down on the chip, and then a certain size window which would then expose contacts on the PCB underneath. You put your chip in there, you'd whack it down like that, and it would conduct through those pads. Let's take a look at those conducting pads under the microscope, because it actually came with spare ones. Awesome. So check it out, we've got the Conductive Pad Replacement Kit, and I don't know how much these would have cost, but yeah, like these things would have, you would change these after, I think they had like a couple of thousand, you know, cycles and stuff. So what it is, let's see if we can go all the way with LBJ here and see what we've got. It's just like little conductive gold flecks or whatever that are isolated, of course, like insulated from each other, but they're just like random gold flecks, and you would actually conduct these things. They would actually conduct through there and connect the pads top and bottom, and that was pretty much it. So it was kind of crude, but very effective, because I never had any problems whatsoever with the contacts on these things. They were fantastic. There we go, that's perhaps a more interesting view. You can actually see the conductive paths right through there. That's great. Love it. A beautiful concept to come up with that. You know, how do you, for a universal thing that could connect to almost any chip using, you know, whether it was PLCC or whether it was, you know, a LAN grid array or something, you know, any sort of, you know, even BGA stuff and things like that, you know, with the contacts on the bottom, you could do anything just using one of these conductive mats. Ooh, look at that. It's a sine wave. Not quite. So I know you want to see what's under here, so let's take it. I'm not sure if this is the correct technique for taking it out, but I'm going to brutalize it. There you go, and it just had that universal contact type pad, and of course all, you know, real top quality gold plating. Ooh, look at the colors, beautiful. And it, of course, you could put any size PLCC on there with that particular pitch, and of course if you wanted a different pitch or a different pin count or whatever it was, or a different style of package, you'd buy another whole adapter like this, because, well, you know, you got to upsell. But yeah, these were so professionally designed and manufactured. These things were bulletproof, worth every cent. And I've been told by Secret Squirrel that this one is actually faulty, but anyway, we don't care about it working now. All we care about is what's inside this bad boy. You know what we say here on the EEVblog, don't turn it on, take it apart. First of all, we want to see what's inside these. Are there any circuitry in there? Is there any protection? Is there any pin driver stuff? Let's find out. Whoop, whoop, there we go, it fell out. Oh, geez. Doesn't look to be much in there, does there? Is that gonna pop out? Yep. It's all through hole, of course. Oh no, look at that. Relays. Relays as far as the eye can see. Beautiful. GI Claire. Never heard of those, but they're obviously going to be top quality ones. DataIO wouldn't have skimped. And we're probably going to find, oh yeah, relay drivers, classic ULN 2803s. They're the ones with the built-in back EMF diode protection. So you got relay drivers and then just 74HC stuff dating from 86 there. Nothing fancy. Oh, that's a bit how you doing. Look at those diode arrays. I guess you could buy those diode arrays. There you go. So they would have had like diode protection on each one of the pins. Wow. Groovy. They obviously had, either they had them custom manufactured for them, or they were like, maybe you could buy diode arrays in that sort of single inline package form factor. Either way, neat. Of course, that's a 4-layer board. It's even got the old school layer count designator there. 1986 for those playing along at home, and got some LEDs. So we got the light pipe up there, nicely designed. They went to town, and little ferrite beads. Geez, they were serious about keeping the EMC out, weren't they? Little ferrite bead in series with every line going to that I/O. Anyway, 7.4, it's just all 7.4HC. Doesn't look to be any custom PAL stuff on there at all. So all the magic is, well, most of the magic, this is just like a pin switching your various voltages. Do we have 40? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, only 28. Relays. Did this one only support a 28-pin device? It's got a 40-pin ZIF socket, zero insertion force socket, genuine 3M text tool. Yes, it is. 3M. For those playing along at home, or you text tool fanboys, and you just know this baby's going to work. It was tested by Doug G. Good on you, Doug. And the main adapter. Oh, look at this bad boy. What a Bobby Dazzler. We've got ourselves some Toshiba parts down here. Now, these would be programmable devices, surely. I mean, oh, look, genuine bodge wire. Look at that. Wow, fantastic. Going all the way with LBJ up the top. Beautiful. Anyway, that's a chicken and egg thing. How would they have programmed these things? On their previous generation programmer? And yep, sure enough, these are a Toshiba CMOS gate array chip. So basically, you know, equivalent to like an FPGA these days, one-time programmable puppies, no doubt. And they would have, I'm sure, DataIO being the programming people, they would have used their own hardware to program these. But of course, this was fancy-pantsy. We're talking, look at this, SO package surface mount stuff. For the most part, the only through-hole stuff in this is the connectors and the relays. Awesome. You know, I'm not familiar with that relay off the bat, but no doubt they would have been really good. I'm actually surprised not to find reed relays in here. These look like your traditional mechanical relays, but of course you didn't have to, like, it's not like they switched these for your data and stuff like that. They didn't need that many cycles. All they were switching was basically the voltage through to a particular pin. So these would only switch, you know, once or a couple of times during the programming of any particular pin. After that, then they'd actually, you know, the data just came through data level buffers and things like that, which they could adjust the level of. But yeah, apart from that, yeah, because they didn't need high cycle count on these relays, but I'm sure they're top quality. And on the back of the board there, there's not a huge amount. There's just a bunch of resistors. They look like caps, but they're actually not. They're resistors. We've got a couple of 7.4, old school 7.4 LS with a bodge resistor on it. No worries. But just a bunch of resistors on there. And also, I missed the little individual driver transistors down in there. Little driver trainings for each one. Of course, these would all be the relay drivers up. Well, it's just like serial interface relay drivers with then the individual tranny to drive each one. But there you go. Brilliant. There's a lot of engineering that goes into that, though. Now, I'd be surprised if this puppy wasn't designed to come apart real easy, because you could... I don't know if it's user upgradable, but you could certainly, you know, buy the base model and then upgrade it later with more pin card capability and stuff like that. I believe this thing might be fully loaded, so took a little bit of coercion, but there we go. Oh, we're in like Flynn, but we're being mooned. I didn't show you the awesome part. Oh, look at that. Wow. Isn't that gorgeous? Look at the pin driver cards. Yeah, this sucker's fully populated, all right? Oh, that's pant-wetting stuff. Look at it. Beautiful. Of course, all the pin driver cards are going to be absolutely identical, but oh, there you go. All that processing goodness. Beautiful. Thing of beauty is a joy forever. This is interesting. Property of H&R ink? Silicon software? Does anyone know the story behind this? Obviously, these are the ROMs, a date code of 87 there, even though it's copyright 95. Did they hire Silicon Software to write it? Is it a subsidiary or whatnot? Anyway, we've got some programmable devices here, and oh, look at our beautiful little bodge there on the pin. Yep, I think we have a genuine lifted pin there. Oh, they've chopped it off, have they? Beautiful. Ooh, remove for kernel test. Interesting. So we just got some jumpers in there. More programmable, GAL type devices here. And of course, it's all like 74LS, 74HC stuff. Another genuine bodge there. Oh, except a 74F for the screaming 40 megahertz clock on there. That was pretty fast back in the day. You'd be using your 74F stuff for that. It's always interesting to note on these teardowns which chips have selective sockets on them. Look at this, 74LS245. I'm not sure if that's a repair or if it's a production mod. I'm not sure, I don't think they would have repaired all those. So, some 74LS244s, 373s, classic stuff. 74LS86 over there. You've got your XOR gate, and, they've got there's a few of them in sockets. They look to be coming out. Have to go around and give those the old press 1-2, but yeah, they got a few extras over there. So they may, decided, hey, maybe those ones, there's advantages to taking them out, either for testing, debugging, or repair purposes. Maybe they're driving stuff they expected them to fail or whatnot. And the 68,000 fanboys have just creamed their pants, I think. And there it is. Oh, it's all rubbed off. People have been intimate. Anyway, that little mod there is on the address select pin, so it's come from this 74F over here. Of course, they need to address it real quick, so yeah, they use the F-series logic. F is fast, if you didn't know. And yeah, so they've tucked a ferrite bead with a resistor going to there. And of course, you've got your classic multi-layer board routing here. You can actually see all the square traces in there like that. All the electrons are going to fall out. This is most likely auto-routed, because no self-respecting designer would add right angles to their traces like that. And of course, all the chips are all lined up in this same vertical direction like this, and all the traces, almost all of them, run vertical on the top side of the PCB, and on the bottom side, of course, they'll run horizontal across the board like that. That just gives your best routing. But look, there's not one of them out of place. I like it. Not one little oddball one mounted at right angles. Beautiful. And that's a 6-layer jobby. There you go. You can tell by the layer count down here, 1, 2, and then you progressively can't see them because they're on the bottom layer. So, of course, they would have had a huge 5-volt rail in there, so a dedicated ground, dedicated 5 volts. The rest probably would have been, you might have done power routing, and they've done some pin routing and stuff like that. Here on the top, you can see all the pins. It looks like you only had to populate maybe these boards here if you wanted the 40-pin dip interface, but if you wanted the expanded one, don't know where the extra traces are over on this side, but maybe they're on different layers or something like that. And that's a reason why you'll find mod wires on these type of designs back then. It was really expensive to, respin these boards, and you'll find issues later. And these things weren't manufactured by the tens of thousands, hundreds of thousands or something, So you could easily add manual mods like that at the production stage, little bodges like that. No worries whatsoever. It's cheaper than respinning the board, that's for sure. Check out the beefy power we got here. All those pin drivers and all this processing. It must take some grunt. And at the bottom, looks like it's just going to have power supply in it. I don't know. There might be a lot of wasted volume in here, although you got your floppy drives, of course. And very curiously, it also came with this expansion RAM board too. So, I don't know, that mounted under the bottom or something like that, perhaps? Anyway, someone pilfered the RAM because, RAM was expensive back then. Still is. Aha, yes, it must plug into here and mount under the bottom somewhere. In fact, I can see another board under there. It came with a base amount of RAM. Not sure what it is, but for those playing along at home who love their RAM part numbers, knock yourself out. But by far the most interesting thing inside this is the pin driver card. Once again, we see that Toshiba CMOS gate array there, but this one dates from '89. Love the right angle dual inline 0.1-inch header there with the soldered on boards. They're very rugged. Love that. Yes, it is actually a dual row. It plugs into the second row down the bottom there as well. But these would have cost a fortune. And check out the density in this thing. Wow, look at that. This is a brilliant layout. So hats off to who's ever laid this puppy out to try and get all that density into that. Like, there wouldn't have been much room left. Would have been tearing their eyes out trying to lay out that puppy. Anyway, very, very nice. We've got ourselves some power transistors down here, 3055. You should be familiar with those. Fantastic. They've got some just some mylar under there, insulating sheet. These obviously aren't dissipating any power, so it's flapping around in the breeze. You know, I don't like the TO220s flapping around in the breeze, but yeah, okay, I don't like it. Anyway, they haven't secured them down, but it's fine. This thing's, you know, designed to sit on a bench, not designed to be moved around and vibrated and stuff like that. And but I love the custom heatsink up the top here. Looks like we've got some IRF 97 something or others there. So we've got some sort of power MOSFET there. What are these little puppies? They drivers for the MOSFET? Have to look those up. So I couldn't find any data on that. If I do, I'll link it in later in the edit. But anyway, look, they're very interesting. 0.285 ohm, 1% resistor. That's obviously some sort of current sense resistor. So maybe this is some current sense amplifier. And look, I think they've got a guard trace going right around all those top 4 pins there. So maybe that's some sort of, you know, amplifier for the... they're obviously doing some pin current sense in there. And we've only 4 MOSFETs there. You've got to wonder, is this like a 4-channel card? And on the bottom here, they've got another 4 trannies. Look at that. They look like bipolar jobs, are they? And yep, that just must be a quad pin driver just based on the configuration there. And that kind of makes sense because there's actually, well, I was going to say there's 16 cards here, but there's actually 17 cards. So 16 times 4 gives you your 64 pin capability. Why they've got the extra card, I don't know. 17 instead of 16? That creeps me out. But this is just insane. All this to drive 4 pins. You can see the complexity if you want to do this properly. You know, these universal programmers these days, I've done teardowns of like a cheap $50 eBay one, which is, you know, fine these days, but it doesn't hold a candle to these, you know, these old school ones which did it properly. You know, these were professionally engineered to basically drive any pin at any voltage, and there's just, wow. How can I find the schematic for this and go through it? And as I start to take these boards out, they've all been like mixed and matched, different flavors. The chip over here is a PMI PM355, and that's a JFET input op amp. So that makes sense with that guard ring that we saw around there. But I've got various dates on these, you know, spreading at least a couple of years apart. I don't see any real differences in them apart from actual, you know, brand differences in the chips and stuff like that. Maybe, you know, some part substitutions, but no, it doesn't look like any board modification changes or anything like that. And as Secret Squirrel told me, this thing, it doesn't actually power up, doesn't seem to do anything. So I've got actually the cards removed here, and let's switch it on. Watch the LEDs over here. And there you go, the power LED just flashed, and that was it. Thankfully, there's some test points here. Just going to test them with all the cards out. So, you know, minimum load on there. All right, we'll just measure some stuff. Oh. That's already on. Oh, well, that's supposed to be a 12-volt test point. Definitely got it on. Yep. It's supposed to be a 48-volt test point. 5 volts? What? What a sausage. I mean, you know, if you don't get your 5 volts, you're not going to boot. Minus 5 volts, and there's a 2.5 volts, but nothing. And I'm just trying to get this board out here, and as you'd expect with a huge multi-way connectors like these, when there's a lot of force when you actually press down, users will just slam them in. These are actually rigidly mounted, so I've taken the screws out of the board. You can see that maybe you can see the bow on that. Obviously it's held down with these steel pins right at the connector. Nice design, otherwise it'd be horrible force on the joints and everything else, so they've done that well. Tell you what, this whole design's quite complicated. We've got two dual inline right angle headers up here going up to this board. Don't know what the hell that thing's doing, but it's good that you don't have to take out the jacks for the D25s, but you got to sort of, you could easily slide that in and bend the pins or do whatnot, but I don't know. Like, they could have done something else with that board. Ta-da! Oh, main board out. Oh, I better bloody turn off the power. There you go. Warning, high voltage. Geez, they don't even have an insulating sheet on that bad boy. But there you go. Nothing in the bottom, except, as I said, all the traces going vertical. A couple of bodge wires. But there you go. Yeah, the rest of the pins over here aren't populated. That's interesting. Are they just like power and other stuff? Maybe for future expandability for a different motherboard or something perhaps? Anyway, that's a big ass board. You certainly need a serious business power supply for a bad boy like this. Look at that. We've got our Nippon Chemicon caps. Look at that. Oh, red. They go faster. SXC series for those playing along at home. They all look in good nick. All the vents, there's no bulges. All the vents look good. And got ourselves some power trannies along there. There's more power trannies along this wall down here. And geez, look at the compound. It's all over the shop. Somebody had fun. Geez, what'd they do? Spray paint that on? Anyway, it's all very neat and tidy. And we come over. Oh, Sprague. Oh, yeah, Sprague. Mains filter caps on the input DC rectified side. There's our rectifier down there, of course. There's our bridge. And everything looks hunky-dory. It's not up to modern standards, of course, but, power supply from the 1980s, fuse is intact down in there. But I don't see any visual signs of distress. I don't smell anything, so, why are we getting 0 volts out of this puppy? I don't know. Aha, found out what the backboard does. Dead giveaway down in that corner. Look, waveform board. So that must generate the programming, the required, waveform slash, in quote marks, programming sequence for the particular pin that they're currently pulsing. That's interesting. It's got a bunch of, what are those up there? They almost look like memory. SRAM chips? No, those are actually PM7545s. These are 12-bit DAX. So this can actually generate analog waveforms, presumably like to control maybe the slope of, that's a pretty over-engineered way to do it. Maybe the like the slope of the programming pulse or something like that, because, or is it, truly so universal that it supports weird-ass analog things? I don't know. Anyway, that dates from copyright 85 down in there, made in USA. And down in here, we've got some analog devices, AD7226s. They're a quad 8-bit DAC. So, it's just DACs all over the place. It's full of DACs. All right, let's have a quick look at the schematic for the waveform generator here. It's 3 pages. Check this out, but so let's go up to the first page here, up here in the corner. We've got ourselves the voltage references, AD851, and the usual transistor driver for that. No wuckers. We've got some 0.5% resistors. Like, it doesn't have to be hugely, or 0.1%, it doesn't have to be hugely accurate. But yeah, I would figure, if you're designing something like this, you want to be 5 point, you want to be a 5 volt supply plus minus 0.1 or something like that. Anyway, here's our 2 DACs, 7545, and we've got a, looks like we've got a transistor output driver here. Check it out, 2905s, and then they're driving some higher power ones. So this is for yet the device under test VCC. So that's the VCC for the chip, and VCC sense. So we're sensing that back, are we? What the, yeah. Geez, they're serious business for generating, you know, all this just to generate the the VCC rail for your device under test. Amazing. Then we've got 3 more DACs here generating 3 different reference voltages. Where are these? Power bus, comparator bus, analog bus. What the? Okay, so it's the analog bus that contains the device under test VCC and all the different reference voltages generated from these 3 different 12-bit DACs. Wow, unbelievable. Let's go down to the overvoltage crowbar. Look at that. Where's that between? 42 volts. Okay, so that must be the absolute maximum capability of this thing. Anything over that, it will absolutely clamp it down with a proper crowbar. It just turns on the SCR and you know, just shorts everything out to protect your device under test. Beautiful. So these are our positive and negative supplies, are they? Plus OC, minus OC. What? Local high and logic low supplies. Okay, so these must be the voltages for the logic levels of the device under test. So if it's a 3.3 volt part, for example, then they're obviously generating those by the looks of it. Plus 21 volts. Fine current clamp. So it's got all these current references. FCLR. So what could it drive? It could drive constant currents into pins, presumably. That's amazing. Unbelievable. Overcurrent integrator. Slew rate reference. So it can actually control the slew rate. So not unexpected to be able to control the slew rate. I think I might have mentioned that before, the ability to do that on the programming rails. And course current supply. Wow. That's great. That is unbelievable. So all that waveform board, just like, that's got more in it than what, probably any other universal programmer currently on the market, except for, you know, the ultra high-end ones. Unbelievable. And here we go. I've actually got the description in the maintenance/service manual. The primary function of the waveform board is to produce several individually controlled voltages for use by the pin drivers. These voltages provide the pin drivers with power to operate. They serve as reference levels to control the pin drivers and provide voltages which are either re-regulated and applied to the part being programmed or switched there entirely. That doesn't tell you much, does it? So are these all the different levels that it can generate? Still doesn't really. Raw voltages. Wow. I'll have to link in all this stuff down below. Great bedtime reading. There you go. You can read that to your heart's content, the functional operation for all this stuff. They don't make them like this anymore. And just look at the capability they've added here. The FCLC power supply is to set a clamp voltage on the pin driver's output when the pin driver's fine current source is sinking current. Unbelievable. Like, you know, 99% of the devices out there will not need this to be able to actually program them, but this is a true universal programmer. And then the other one is for the fine, does the same similar thing, but for the fine current source. Unbelievable. And, you know, they've got 12-bit DACs to do this. And then they've also got a dedicated clamp voltage as well, so that's what those diodes were on the, you know, those single in-line package diodes were to clamp the individual pins. They actually programmed the voltage that goes onto the common of those diodes so that the pins cannot go like 0.6 volts above whatever you program the clamp voltage to be. That's fantastic. And it looks like the power supply is from Computer Products, Boschert Incorporated, certified by manufacturer to comply with IEC 348. Thank you very much. So I had a quick poke around in the power supply and cleaned it up, and I've put it back. There wasn't anything obvious, so that'll have to be a separate video troubleshooting that, because I'd love to get this baby up and running, because I have no doubt all the digital stuff, it all still works. All the pin driver boards, it still work. I have no doubt if we got the power supply up, I'm pretty confident this sucker would still work. Floppies, yeah, they're pretty reliable. 720K floppies in there, they'd still work a treat. And if we actually have a look at the newfangled TaskLink software, because it didn't always use this TaskLink software, I don't know where they got that name from, but it used to use the Hi-Rise software, it was called. That's the one I used back in the day, and that was not only terminal, but like a DOS-based software. Anyway, you could also get TaskLink for DOS as well, and then they progressed over to Windows. And this software supported the different systems, of course, and the Unisite stuff down here. And this software dates from 97. This is version 3.1 or something like that. But if we go in and we actually select device, it's actually quite telling in what it supports here. I mean, let's go down to something that might be familiar to you youngsters out there, which would be some microchip stuff, for example. So these did support micro control. Can I just type in microchip? That'd be easier, wouldn't it? Microchip, there we go. And it did support microchip microcontrollers, as well as microchip memory and E² PROM and EEPROM and everything else back in the day. You'll notice that they're all like the 1612C. They're all the C versions. There's some of the E² PROMs, I believe there are. But yeah, you'll notice that what's missing is some of the new F series stuff, which of course use, there's the 17 series, but they're all the C, the one-time programmable, or either the one-time programmable type or the reprogrammable type E² PROM version. So they don't support any of the flash stuff, because that's, I think, was there one there? Oh, there was a couple. Okay, the 16F84 was basically the first flash programmable micro on the market, I think. And it's the one that, changed everything. Basically make microcontrollers what you think of them today, with the built-in reprogrammable flash memory. And that's pretty much when, not just the microchip parts, but other types of microcontrollers started getting their own built-in programming stuff. So you didn't have to apply a high voltage external pulse like you did with some of the early 16C series PIC stuff. You had to actually apply a higher voltage. You couldn't just program them with your 5 volts or your 3.3 volt system voltage. But once they changed over to the flash memory and they had built-in boost voltage, it just took care of everything for you inside the chip. And all you did is you hook up your 5 volts or your 3.3 volt signal to there, and, Bob's your uncle. You could program this using a $10, serial parallel adapter or something like that. You didn't need these big universal programmers that knew how to test these things over, at the right voltage with the right algorithm and everything else. Everything else was, the programming stuff was all handled inside the chip. So that's pretty much when these universal programmers became less relevant in terms of being able to actually properly support the algorithms for all the different types of chips and the both voltage and data algorithm type stuff. So yeah, that's pretty much where it ended. But apart from that, you probably wouldn't notice anything different with the universal programmer software that you'd get these days for your cheap, $50 programmers and things like that. It has the step-by-step processes, the blank check, the program device and verify device and stuff like that. But in the case of these universal programmers, it could actually put, when it verified, it could actually put extremes of the voltage rails in there and verify it over a much wider range and things like that. So yeah, this thing was the duck's guts back in the day. So although you can buy universal programmers these days in quote marks, they're not quite the same thing as these old school universal programs, which could generate almost any voltage and put it onto any pin in any configuration and things like that. This thing wasn't necessarily the fastest thing out there, not by a stretch, but if you wanted to program a device properly and have it guaranteed certified reliable, then this was the way to do it. So there you go. I hope you enjoyed that vintage teardown of the classic DataIO Unisite programmer. And this baby was the reference standard for several decades. Unbelievable the support that they had behind this, and unbelievable the amount of effort they went to design a true universal programmer. Or, you know, that's just 4 channels. Like, compare that with a modern teardown of a little tiny universal programmer I've done that, you know, which is okay for today's modern devices, but, you know, if you truly want to cover everything on the market from, you know, the 70s onwards, then only something like this would do the job, really. But as always, like, you know, you can get similar capabilities to these days as technology's marching on. You can, you know, get this in a smaller form factor, USB interface, all the rest, all the works and stuff like that. But, you know, modern devices, you know, you don't need to program them with, you know, 20-something volts and stuff like that. So it's a little bit different. It's sort of like a backward compatibility thing. But, you know, if you want to program modern stuff, then, you know, just this little mini pro that I've done a video and teardown on, or something like this, you know, well on one, which are universal programmers for modern devices, don't have nearly the same capability as something like this, but for modern stuff, more than good enough. It's all in the software, pretty much. You know, the interface to actually drive the chip isn't that hard at all. Just a bunch of serial drivers and protection and whatnot, and Bob's your uncle. But yeah, you can't beat that. That was the duck's guts, and to a lot of people it still is. Hands up if you had one of these, or hands up if you still use it. Or maybe a later variant of it. Discuss down below. And as always, if you liked it, please give it a big thumbs up. Catch you next time.